Knowing how to debug is one of the most vital skills in VBA. In this video, I'm going to teach you everything you need to know so you can debug like a pro. So this video will cover what is debugging and why do you need it, how to access the debugging tools in VBA, what each tool is for and how to use them, and then we'll look at putting it all together, the SandBox method, so using the SandBox method to dramatically increase your knowledge of VBA, and example 2, finding and fixing an error in VBA using the debug tools. So let's go ahead and get started. If you like this video, then please click on the like button, and if you'd like to get notified of my upcoming videos, then click on the subscribe button and the bell icon beside it. What is debugging? Debugging is simply stepping through our code line by line as it runs and checking the values of variables. So that's debugging in very simple terms. Why do we need to debug? Well, we do it to find errors in our code more easily, especially more complex ones that are not easy to locate. And secondly, we do it to gain a deeper understanding of how the code works. So what are the debugging tools? Well, there's basically two types of debugging tools, and you'll find these under the debug menu in the Visual Basic Editor. These tools basically either help us step through the code or check the variable values. Let's look at a very simple example of stepping through the code. You can see here with the yellow lines that we're stepping through the code one line at a time. Now, when we put the cursor over one of the variables like total, you can see total equals 0. Now when we move on one line and we do it again, you can see total now equals 60. And we step on one more line until we reach the end. So this is a very simple example of debugging the code, and all the tools that we look at basically enhance this experience. The Debug Toolbar is very useful when you're starting off. Now, after you get more familiar with debugging, you can use the shortcut keys, but everything you want is here. Now, if we right click and we select debug, you can see that it disappears. So if it's not there, you can right click and click on debug, and that makes it appear again. So very useful for any of the toolbars. You can drag the toolbar left, right, up, down, wherever you want. You can even drag it out so that it's floating. And this is quite useful when you're debugging. Now, double clicking, you see, brought it back, and then we can drag it wherever we want. So we're going to drag it out here so that you can see it when I'm debugging. So if we click in a sub and we click on step into on the toolbar, or we press F8, which is the shortcut key, we can step through the code one line at a time, as you can see that I'm doing here. Now, at any point when we're stepping through the code, what we want to do is we want to see the value of variables. So we want to see what state our code is in at any time. Now, we can put the cursor over a variable like we did already, and you can see that it'll give us the value. But sometimes if we want to look at a lot of variables in one go, it's kind of annoying to have to keep putting the tooltip over them all, and that's where the locals window comes in. So the local window under view, locals window, and what this does is it basically just displays all the current variables, and we can double click on it here just to make it float so we can see it better. And you can see that it has total and name, so it automatically fills the locals window with whatever are the current variables. Now we're going to put in another variable just to demonstrate this. So let's have one, we'll just say dim C as currency. And now when we step through, you can see that C appears now in the list. So the locals window is very useful. We want to be looking at all the variables as we step through it and just see the different changes that are occurring. The locals window is useful for basic debugging, but it's also quite limited because this is really all you get. It puts in the variables and you can see their values, but you might want to look at more maybe advanced things when you're debugging your code. So that's where the watch window comes in. So if we do view and we do watch window, you'll see the watch window appears at the bottom. Now, to add an item to the watch window, we can double click and just drag it, or we can just right click and we can just say add watch. So if we right click on an actual variable and say add watch, it'll fill in the variable for us. And we just click OK. And now you can see that our variable is there. Now if we double click, like with all these windows in the Visual Basic Editor, it will float the window, pop it out as you can see. And if we click on a variable in the watch window, we can change it. So for example, we could say, what's total multiplied by 26? And now when we step through the code, you can see that it's calculated what the total should be. So we could add another one. We could say, what's total multiplied by 78? and you can see it gives us the value. So this is often very useful when we're debugging to see more than just the basic variables. So a very powerful thing that the watch window can do is it can run functions. So for example, if we put name into our watch window, we can use the left function. So we can say left name and give us back the first character, and you'll see that the result in value is J. Now we can do it again. For example, this time we're going to use the right function. Now what we can do is we can also run our own functions. So imagine we create a function like this, and this function, all it's going to do is multiply the value we give it by 10,000. So you can see that we're calling it here. Now when we step through the code, what we're going to do is we're going to put calc into our watch window. So our total at the moment is 70. And if we put calc into the watch window, it should return 700,000. And you can see that it does. Now we can also change the watch so that we just put in any value we want. So I'm going to put in 7. And now you can see that the value returned is 70,000. So this is very powerful indeed. Now one thing, it's very important not to do this with very complex functions that might have lots of lines of code. So only do it on functions where there's a few lines of code and it's doing something quite straightforward. So now I'm going to show you some very useful properties that you can use in the watch window. And these are ones I use all the time. So imagine you've got some code like this where it's not really obvious what the range is and it's not obvious what the worksheet is. Because it's active sheet, it could be anything depending on what's selected as we run the code. So imagine you come across this code and you're trying to figure out what's the range. Well, you can do it in a very simple way by taking the range variable and just putting in the address property in the watch window. And that gives us back the address. And this is something I always do when I'm trying to fix errors to ensure that I'm looking at the correct range. Now another thing that we can do is if we want to be sure about the worksheet, we can do range parent. And the parent of a range is a worksheet, and then we just use the name property, and that gives us data, which is the worksheet. Now if we wanted to get the workbook, it's actually very similar again. The parent of a range is a worksheet, and the parent of a worksheet is the workbook. So we just do parent and then get the name of that, and you can see it gives us back the name of the workbook, which is debugging.xlsm. So these are very useful properties, and I use them all the time when I'm debugging my code to try and fix errors. Now I'm going to show you a common technique I use with the watch window when I'm trying to fix an error. So imagine we get a type mismatch error in our code like this. So you might look at the line of code and wonder where to start. But what you can actually do is you can just drop the whole lot into the watch window and keep separating the parts of the line until you find the error, or until you isolate the error. So for example, we dropped in commission, it looks okay. Now we drop in the other part, and you can see that that has the type mismatch error. So we've narrowed down where the error is. So if we drop total in, you can see total is fine. And then we'll drop in the range C2. And you'll see that it gives us back A567. So we know that that is not a number, and that's why we're getting the type mismatch error. Now we can check it out. Imagine we didn't know that this would give a type mismatch error. We can just add 100 to it to see what happens. And we can see that it gives us a type mismatch error. So the problem is definitely not with the total variable. The problem is trying to add 100 to the value. And this is really just the tip of the iceberg to what you can do, but you can see that it's a very useful way of isolating your error. So let's look at the different ways of stepping through the code. Now we're using step into, and what step into means is that it steps through the code until it comes to a call to another sub or function. And then if we keep stepping into, it will actually step into that sub or function. You can see again it stepped into level 2. So what this means in simple terms is that it's basically going through every line of code that you've written as you would expect it to. Now the second one, we can start again by doing step into. And the second one you can see on the right is step over. Now step over is kind of the inverse of step into in that it won't step into a sub. But the key point to remember here is that it does still run the code. It's basically just pausing the code in the line after the sub. So it's basically still running, but just pausing in the line after the sub. So this is similar to using breakpoints. So let's have a look at breakpoints. If we click in the left on a line of code and then run the code, it will pause on the breakpoint. So clicking in the left creates the breakpoint. We can also use F9. Now, anytime we run the code, as soon as it hits a breakpoint, the code will pause. And you can see it pauses in the different places. Now we can turn them off, we can toggle them on and off clicking in the left margin. Now if we put a breakpoint on total 8 here, and now we're on call level 1, if we run the code it'll pause on total 8, and this is exactly the same as if we do step over. Step over will run the code in level 1, and then it will pause on total equals 8. Now the reason for this is obviously because when you're stepping through the code, you want the code to behave just exactly as if you were running it normally. And if you skip a sub or something like that, then the code is going to behave differently and might even crash or cause some kind of error. Now the third one that we use is what we call step out of. And step out of is basically what it says. It'll basically leave the current sub or function and it will start on the next line outside of the call. So let's look at an example of that. We step into the code again and let's put a breakpoint on level 1. So let's run the code onto level 1. Now the code stops here, and if we do a step out of at this point, it will step out and go to the line total equals 8. So you see step out, it stepped out of the sub and went to the next line after the call. Now if you're still a little bit confused about the difference between the three of them, well then just practice them all a few times and you'll pick them up pretty quickly. So VBA has a run to cursor option, and run to cursor is essentially the same as using a breakpoint. So if we right click, you can see run to cursor, and this will basically mean the code will run until it gets to the cursor and then it will pause. Now I don't see any real advantage to doing this, as you can just as easily use a breakpoint. So maybe there's some cases where it's slightly advantageous, but in general I like to use a breakpoint instead. So one tool that can be very useful is the set next statement. And in some cases when you're debugging through the code and you see some code has gone wrong and you've gone past it, you can use the set next statement to set it back to a line, a few lines previous or wherever you want, and then run it again. So in this example you can see that our code printed out 3 and we realize, okay, this is wrong. It should actually be printing out 4. So we change total to 6 and then we right click and we do set next statement. And now we can run the code again over these lines. And you see that we got 4. Now it's not recommended that you do this too much. It's okay when you're testing out code and you want to see if the changes made a difference. Got to be careful doing this because sometimes it can cause the code to behave a bit differently than normal. So one thing that's very useful when we're debugging is the call stack. Now you don't need to use it a lot, but when you do need to use it, it's very useful indeed. So imagine we've got 3 levels like this, and let's run the code to level 2. Now sometimes when you're running the code, you don't actually know which sub is calling the sub you're in. So we can use the call stack and that will show us the stack of the subs. So the one at the bottom is main, the one next is level 1 and then level 2. So you can see in reverse order the way they're called. Now if we double click on one of them, you can see the green arrow or triangle you could say that appears on the left, and if we click on main you can see the green arrow. Now it doesn't make much difference here because obviously the code is very simple, but when you've got a lot of code in different modules it can be very useful indeed to bring you to the calling sub so you can see exactly what is happening there. So another simple tool that's very useful at times is the show next statement. So imagine we've got lots of code, we're in a different module and we can't remember where we left the cursor. So we can't remember the last line that we paused the code on. So what we can do is we can just right click and select show next statement, and this will bring us back to the line that was paused. In other words, the line with the yellow highlight. It's very useful because you can leave where you are in the code and look at code in other modules and then very easily get back to where the last code position was. So what if you actually want to pause the code at a particular point in a loop? So say for example, we want to stop at position 200. So when I equals 200. Now we can step through the code line by line, but that's going to take us 200 times. And imagine the loop was bigger, or imagine we wanted to get to position 5000. Well, obviously this isn't feasible. So what we can do is we can create a special type of breakpoint. So as normal, we just right click and select add watch. And then what we do is we say I equals 200. So we want it to break on this, and then we click break when this value is true, and we click OK. So now when we run our code, what you'll see is that it stopped when I equals to 200. If you look in the watch window, you can see that I equals 200, that watch, the value is true. So this is a very useful technique indeed. Now we can get even more creative by doing a watch this way. So for example, imagine we want to stop at every time that I is a multiple of 50. We can do I mod 50 equals 0, which means 50, 100 and so on. Click OK, and then when we run the code, what you'll see is that it stops on 50, 100, 150, 200 and so on. So this is very useful indeed when we want to stop our code at a particular point in a loop. Most people think about debugging tools as a way to find errors, which of course they're very useful for. But a second thing that debug tools are very useful for is understanding our code. Now imagine you want to add a collection to your code, but you don't really know what a collection is. Well, what I would recommend you do is open a new workbook and start adding lines, kind of sample lines of code about using a collection. And then you can use the debug tools to step through the lines of code and see exactly how the collection works. So for example, now we can bring up the watch window or the locals window, whatever we prefer, and we can see what's going to happen when we step past the collection add line. So we step past the line and you'll see a plus appears beside the collection. So we click on the plus to expand, and we've got one item in our collection, and it's at position item 1. Now we step past the next line and you see now we've got orange. So now by doing this you get an understanding of how the collection works. So we can try other things, and the other things we can try, like for example remove or whatever functionality we want to test out. And then we can go through the code line by line and really understand it. Now the beauty of this is that because it's in its own workbook, it's not affecting the code in our application. So we're trying it in the sandbox as we say. And the second thing is the code in our application isn't affecting this code. So we can look at it in isolation and really understand it. And the debugging tools make it just really easy to see exactly what's happening. And it also allows us a very simple way to really understand how VBA works. So this is the SandBox method, and I use this all the time when I'm trying new techniques in VBA or different languages, and I recommend that you use it yourself and you'll find it very useful. So far we've been looking at the debugging tools individually. So let's now see a real-world example of how we would use them together. So here we have an application taken from my Excel VBA handbook course, and when we click on view matches, we're only getting back 3 matches with Spain, and we should be getting back 6 matches. So our job is to find the error in the code. Now when something like this happens, initially you have no real idea where the error could be occurring. So we're going to start by putting a breakpoint in our create report. This is our click event, so when we click on the button it hits this. So you can see we clicked on the button and paused the code, and now we're stepping into the code. So we step into turn off functionality. We can see that this isn't really relevant to our error at this time. So what we're going to do is we're going to step out of it. And remember, this will still run the code, but brings us to the next line. Now we're going to step over clear report area and then step into create team results, because that's where we presume the error is being caused. So we look down through the code, we see that it's opening the workbook and so on, and we think our error is going to be somewhere around the for loop. So somewhere after we open the workbook and read the data. Because if it was before that, we'd know, because we'd be getting a different type of error. So we run the code, and you can see it opens the workbook, and it stops us on the line where we put the breakpoint. Now what we're going to do is we can check the team, but the problem is that we have to keep going through the loop until we find the team is Spain. So instead of doing that, we're going to add a watch that says if team 1 equals Spain, then break. In other words, pause the code. And we're going to add a second one for team 2, just in case team 2 is Spain. And again, we'll break when the value is true. And then we'll just put in 2 watches so that we can see what the value is at the time. So we just drag and drop both of these into the code. Now we'd get rid of our breakpoint, we don't need it, and let's run the code on. And you see the code stopped where team 1 equals Spain. And we can see team 1 is Spain, team 2 is Chile, but that's from the last time team 2 was set. So we'll run it down one more line and we can see team 2 is Switzerland. So let's step through the code It seems to be working okay. It's assigning a value and writing it out. So let's see what it wrote out. And you can see it wrote out the first record. So clearly the code at this point is working okay. So let's run it on again. And again it stops where team 1 equals Spain. And we'll step through the code, and now you can see team 1 is Spain, team 2 is Honduras. And as we step through that code, it seems fine, and again it writes it out to the worksheet, so it seems to be okay. Now it stopped again, and this time team 2 is Spain, and when we step through the code you can see it didn't enter the if statement. So for some reason there's something wrong with the if statement. And now if we look closer, we'll see that team 1 is Chile, and team 2 actually the variable is team 1, and this should be team 2, because in other words we're basically saying we're comparing the same thing twice. So this actually should be team 2. So we can see where the mistake was made. Now what we can do is we can right click and we can set the next statement to be here. And this is like the first check to see if it's okay. And then when we step through the code, you see that it stepped into the if statement correctly. So we run it on, and what I'm going to do is I'm going to disable these watches, and I'm going to just disable them by just saying Spain XX, because it obviously won't compare to that. Now I can delete them if I want, but the reason I'm leaving them there is just in case we haven't solved the problem, we might want to come back and use them again. So now we run on the code, and let's check our results on the worksheet, and it looks like it worked correctly. But there may have been a side effect from using the set next statement. So it's always a good idea to just run the code again from the start, just to run it as it would run normally, and just see what kind of result we get. So we run it again, and indeed it seems to have worked fine. So that means we've found the error in our code. So this is a kind of real-world demonstration of how to find errors in VBA code using the debugging tools. Now if you want the source code for this video, you can download it from the link in the description. If you like this video, then please click on the like button, and if you'd like to get notified of my upcoming videos, then click on the subscribe button and the bell icon beside it.